Hi, Dan Kelly here. This is just going to be a quick little video showing a little bit about what you can do in Julia. Sometimes I find it's easier to have someone talk to you instead of just trying to read the text. Um, okay, so I'm on a web page here. It's a video, so you could stop it if you wanted, but it's my GitHub page, and the name of the Dan Kelly is my name there, and it's oceananalysis.jl. So that's what I'm on. And if you click on this blue link over here, you get a kind of documentation thing. And there's a bunch of stuff. There's information on all the functions in the package, etc. But we'll go to examples, and I'm just going to show you CTD data. Okay, so this is just some examples with CTD data, and the goal is going to be to make these plots. These are called profile plots in oceanography. So it's showing as a function of pressure in the water column, it defined as 0 at the sea surface, and it's in what's called a decibar, and a decibar corresponds to a meter. So this is showing about 45 meters of water. It's near Halifax, Nova Scotia. And I'm going to show you how to make these plots. And one plot is showing a form of temperature, another one of salinity, that's the salt concentration, and another one of what's called density anomaly. The actual density of the water is like where I'm pointing. See the 22.5? That means that the density is 1022.5 kilograms. But it's too long to write the 10 at the beginning, so it's oceanographic convention to just write the last digits like that. And I'll show you the code that makes this. So the first thing is we'll be using the OceanAnalysis package, the measures package, the plots package, and the printf package in this example. And if you don't have any of those installed, when you run that line, it'll say, do you want to install it? And just press yes or whatever it is that you're supposed to do. And once that's done, take a little while to happen. But after that, if you run the using line again in Julia, it just takes, I don't know, 20 seconds or something to start up. So the next lines here, what they're doing is defining a file name. This is a kind of an arcane, there's another way of doing it. It's kind of an arcane way of finding a built-in file. What it is that there's a built-in file that comes with this ocean analysis package named ctd.cnv. And that's from one of the manufacturers of CTD instruments, which is the workhorse instrumentation for oceanographers. A CNV is a kind of proprietary format. So this can read that. How do we read it? We say read.ctd, read underline CTD underline CNV, give it the file name, and we're saving it into something called CTD. If you run this interactively, it just you can then type of paren CTD. It'll tell you that it's of type or class, or I guess it's called a type, capital C and then lower TD, CTD. Okay, that's fine. Then we're going to make 3 plots. We're going to make a profile of conservative temperature. The abbreviation is CT. And then another one of absolute salinity. The abbreviation is SA. And then another one of this density anomaly, and the abbreviation is sigma 0. These names are oceanographic standards. And so the function that's being used is called plot profile. You give the object, and then you say semicolon. After a semicolon, you can give named called keyword arguments. Notice I didn't say a name for CTD, I just gave the CTD object. Now I'm saving these plots as calling them P1, P2, and P3. What I'm doing in the next line is I'm making a title. I'm using sprintf, that's why I need the printf package. By the way, I need the plots package for doing that. And yeah, so the printf, so this is, it's a little arcane, but this is just a way of making the label that you see at the top there. And when it says CTD square bracket quote, it's grabbing square bracket quote has been defined by the package to mean try to look up the string, the data that's in the string. And so that's good. It's done that. And then what we're doing in this line is we're plotting the 3 of them, and we're giving a layout. So you just name as many plots as you want in there, and you give a layout. I've got 3, I want them side by side. So I say this thing is called a tuple, like a tuple. Could have some number of elements in it. In this case, it's got 2 elements in it. And that says 1 by 3. So they're going to be 3 columns, 1 row. And I'm giving the size. I don't know why I'm doing that. So I'm doing that. And I'm telling the margin between them. And oftentimes I do alter the margins a little bit just to make it look a little nicer. And I wanted to show you in this, that's how you do it. Well, that's why I need measures. when you've got measures, then I can say 0.25 centimeters. DPI is the resolution, and I'm giving the whole plot a title. The plot title would normally be in a much larger font. I don't like it. So here I'm using a font size of 11. The default font size otherwise is what's called 8. And then finally, I'm saving the figure that I just made. If you run all the lines above interactively, you'll see a 3-panel plot. But if you want to save it somewhere, you do save fig. If you want to save as a PDF, you just change the suffix here to PDF. Yeah, well, that's maybe the main thing I wanted to show you. There's lots of examples in here, how to work with acoustic Doppler data, all sorts of different things. Here's a section plot. You'll see in this one, I'm doing a kind of an extra thing here in which I've got this top row here has only one plot in it, and these have two. So I'm using the at layout syntax for that. Notice the semicolon in there. And I can actually give widths for these. I could adjust the widths of all these. It's very flexible in that way. This is all Julia that I'm showing. I think that's what I've wanted to show. So thanks for watching.